Now, let us concentrate on some of the examples, right, which appears to be coming in the interviews, right? So, how we can solve these problems in an efficient way. Now, there is one basic example. Okay, this is quite common, repetitive example. Compute, compute XOR from 1 to n. Okay, suppose if they give n is equal to 4, you need to calculate 1 XOR, 2 XOR, 3 XOR and 4. This is the result we have to find out. Okay, so see, there is one name method that we can use. Name method means the very basic method that we can use to solve this problem, right? If you think of this, right, name method, how we can do it, right? So the very basic way is we will declare one variable I and n and XOR, okay, like this. Initially I'll keep XOR is equal to 0. Now we will run a loop I is equal to 1, I less than or equal to n and I plus plus, and every time we will keep on XORing that I value, XOR of I. This is a very, right, uh, basic method. Okay, now what happens in this one is you need to run a loop, right? The time complexity of this will be big O of n, right? So you can optimize this logic, you can optimize this code also, right, using a direct method. Okay, now if you go with a direct method, right, you need to understand certain things here. For example, binary of 1 is what? Okay, binary of 1 is 0001. Okay, binary of 2 is what? Okay, what is 0? Okay, 2 is 0010. Binary of 3 is what? 0011. Binary of 4, 0100. 5 is 0101. 6 is, okay, 0110. 7 is 011 and 8. Okay, we will consider only few in the beginning. Okay, so that you can see certain pattern in this example. Okay, you can see certain pattern in this example. So 8 is what? 8 is what? 1000. Okay, now if you perform XOR of these two, okay, if you perform the XOR of 1 and 2, right, when n is equal to 2, if you perform the XOR, what will be the result here? Result will be, what will be the result? It will be 3. If you perform XOR of these two, that is 0001, 0010, the output will be 3. Okay, output will be 3. Okay, when n is equal to 2, right, when n is equal to 2, right, output will be 3. Now you perform XOR till here, XOR of all these three, 0001, 0010. You perform XOR first two number, this is 1 and this is 2. If you perform the XOR, then perform with this result, XOR it with 0011. Okay, this is number 3. When you XOR all these three, the result will be 0. When n is equal to 3, the result will be 0. Okay, result will be 0. Now till this point the result has become 0. Now what we will do is, when we take n is equal to 4, So n is equal to 4 means what? Previous to that, till 3, the result was 0 0 0. Now if you take n is equal to 4, so binary of 4 is 0 1 0 0. When you perform XOR operation, right, you will get the result as 4 only. Result as 4 only. Okay. Now when you go up to 5, when n is equal to 5, right, like this you observe, when you take n is equal to 5, okay, so till 4 it was what? 0 1 0 0. And when you need to XOR 5 also with this one, so this becomes 1 0 0 1. The result becomes 1. Result becomes 1. Okay. Now like this, right, like this you keep on doing it for some sample n values, right? So 0 0 0 1, XOR it with 6. This is the previous till 5. Now XOR it with 6. How much do we get? Right? We get 7. So the result here it becomes 7. When n is equal to 7, the result becomes again 0. Okay? Result becomes again 0. When n is equal to 8, the result will be 8 only. Now, what you need to observe is certain pattern. Okay, so XOR gate, how many different type of inputs we will give? For XOR gate we will give 4 inputs. So the 4 inputs. Okay, so now look at these pattern, right? Look at this pattern. Okay, right, if the number is multiple of 4, if the number is multiple of 4, then the result will be same always, right? If you observe this carefully, okay, if you observe this carefully, if the number is multiple of 4, if the number is multiple of 4, so what we can do is we can use modulus operator. Let's say XOR is equal to n mod 4. Okay, if the number is divisible by 4, the remainder will be 0. So if x is equal to 0, if the remainder is 0, means the number is multiple of 4. Then the answer will be always, right, n only, right? N, the answer will be always n. Now if you look at, if the remainder x is equal to 1, if the remainder is equal to 1, right, so when does the remainder will be 1? Right, look at this combination, look at this combination. Okay, so right, I think n is equal to 1 I have not taken. N is equal to 1, the output will be 1. Okay, so if the n value, right, is 5, or if n value is 1, right, so remainder will be, right, if n value is equal to 1 or 5 or 9 or 13, right, the remainder will be always 1. In this scenario the answer will be always 1. The answer will be always 1, right? Now, if the remainder is equal to, if the remainder is equal to 2, right? If the remainder is equal to 2, for example, right? You look at this, you look at this, right? If the remainder is 2, right? If the remainder is 2, sorry, if the remainder is 2, right? So if I give n value 3, 3 mod 4, sorry, n value is 2, 2 mod 4 is what? Remainder is 2. If I take n value as 6, 6 mod 4 is what? It is 2. So in that cases, the answer will be always, right, n plus 1, n plus 1. Okay. Now another input that you have to observe is, right, another input that you have to observe is, right, when the remainder is 3, when x is equal to 3. So there are only four types of inputs, sorry, four types of results when you perform mod operation of a number with 4. If you mod any number with 4, only four values will come: 0, 1, 2 and 3. Okay. Now in this situation, right, in this situation, okay, you check with, okay, a value called as, right, this one, when n is equal to 3, when n is equal to 3. Okay. And when n is equal to 7, when n is equal to 7. So if the remainder is 3, then the answer will be always 0. So this is called as direct method of computation. Direct method of computation. So if whenever you want to, right, whenever you want to compute XOR, right, of, right, XOR from 1 to n, you can directly use this direct method to get the use. So this will be the most efficient one. Okay. So let's write a code for that. Let's write a code for that. Okay. So what is the question here? The question says compute, right? I'll write down the question here. Compute XOR from 1 to n. Okay. So for that, right, we need one value as an input from the user: scanf percentage d double quote comma ampersand n. Take that value from the user and write printf result is equal to percentage d double quote comma compute XOR and pass n value as a parameter. You call a function now called as compute XOR. So what does this function will do? This function will compute the XOR from 1 to n. Now what we will do? We will check if, right. So what we will do here? First we will check if n mod 4 is equal to 0. If the remainder is 0, what will be our result? If the remainder is 0, the answer will be n. So if this condition is true, return n. Then check another condition. If n mod 4 is equal to 1, if n mod 4 is equal to 1, n, if n mod 4 is equal to 1, what will be the answer? The answer will be always 1. So return 1. What is happening? Okay, fine. Okay. Now, if n mod 4 is equal to 2, if the remainder is 2, then you check our calculation here. If the remainder is 2, if the remainder is 2, the answer will be always n plus 1. The answer will be always n plus 1. Okay. So what we have to return here? Return n plus 1. Then if n mod 4 is equal to 3, if the remainder is 3, if the remainder is 3, then the answer will be always 0, right? Then the answer will be 0. Okay. So this is the way we compute XOR from 1 to n using a direct method. It's a direct method. Okay. You can check here. If I give 3, the result is 0, right? If I give 7, not 7, let's give 5, so result is 1. So if I give 8, the answer will be 8 only, right? So if I give 7, it will be 3. If I give 1, the result will be 1 only. So this direct method formula, we have derived it by performing the XOR of 1 XOR 2, sorry, 0 XOR 1, XOR 2, XOR 3, XOR 4, XOR 5, XOR 6, XOR 7, XOR 8. So we performed all these XORs and we have written the results here. Okay, we have written the results here. Based on these results, we have derived these direct answers, right? Because it keeps on repetition. Why are we doing it with mod with 4? Because you take a XOR gate, we give only 4 different type of inputs. These are the 4 different type of inputs, which are nothing but 0, this is 1, this is 2, and this is 3. These are the inputs what we give to the XOR gate, right? So using, right, these total 4 numbers are there, that is why we will mod it with 4. So this is the direct method. And this one, using a loop you can perform the same operation, but a loop will take more time compared to the first one. Are you clear about it? Are you clear about it? How to compute the XOR from 1 to n using a direct method. So let's go for the next question. Count of numbers, that is x, smaller than or equal to n, such that n plus x is equal to n XOR x. See, this is, okay, this, there is a mathematical relation between addition and XOR. If you check with the addition what exactly the results will come, just like a formula what we have taken. Okay, so what you have to do is, if you write down, right, you write down n is equal to 4. So what you have to do is, right, what you have to do is, you should take 4 plus 0 is equal to 4 XOR 0. 4 plus 1 is equal to 4 XOR 1. 4 plus 2 is equal to 4 XOR 2. 4 plus 3 is equal to 4 XOR 3. 4 plus 4 is equal to 4 XOR 4. Okay, so you need to check how many of these combination will be equal to each other, addition and XOR, right? So there is a mathematical driven formula by looking at a binary of these numbers. Okay, by looking at binary of these numbers, right, what we can do is, okay, so you need to count the number of zeros in the given number. So if I give n is equal to 4, what is the binary of this? 0 1 double 0. So how many zeros are present on the right side before the set bit comes? Okay, you need to count how many zeros are there, right, how many zeros are there before or in the entire number. This is the binary of 4. Okay, so we have two zeros. So what we have to do is, step 1, okay, count number of zeros in the given number at the binary, or number of unset bit, that is what we need to count. Okay, that is what we need to count, number of zeros, right? Once you get that count, then step 2 is, right, return, right, 2 to the power number of zeros. For example, right, you take this number which we have written here, n is equal to 4, and binary of this is 0 0. Let's say number of zeros, let's call it as x, is equal to 2. Now the answer for this question will be, right, 2 to the power x, which is equal to 4, right, which is equal to 4. Now you take a sample number as 15. You take sample number as 15, right? You take another input, n is equal to 15. So what is the binary of 15? Binary of 15 is 4 ones. Now how many zeros are there? How many zeros are present here? Number of zeros, x is equal to 0. So now your answer will be 2 to the power 0, which is equal to 1. So, right, if I give n is equal to, if I give n is equal to 4, n is equal to 4, there are only 4 combinations are there. There are only 4 x values are there. There are 4 different x values which will satisfy this condition, which will satisfy this condition. Now, if I give n is equal to 15, then there is only one x value which will satisfy this condition. Now you take n is equal to, let's say n is equal to 8. Let's you take n is equal to 8. So here not n is equal to 8, you take n is equal to 9. Okay, so what is the binary of 9? 1 0 0 1. So how many zeros are there? Number of zeros, right? Number of zeros. These are directly mathematical formulas which are relations which are created, right? We are directly using them. Okay, okay. Now x is equal to 0. So here, right, sorry, number of zeros, x is equal to, how many zeros are there? 2 zeros are there. I'm sorry on that. Now our answer will be, right, 2 to the power 2, which is equal to 4, which is equal to 4, right? There are 4 different x values, right? If I give n is equal to 9, there are 4 different x values which will prove that this condition is satisfied. Okay, there are two ways of solving this. One is name method, right? One is a name method. How do we solve that with a name method? Okay, 1 second, I'll just keep the code of previous one. I think it's not required. I'll just write it here. Okay, name method. So how do you solve with the first method? Right, first method is, right, if I give n is equal to, let's say, 15. Okay, now what we will have to do is take for loop, run it from 0 till I less than or equal to n I plus plus. In that, right, write a condition if n XOR, sorry, n plus I is equal to n XOR I. Whenever this condition is satisfied, you count it. Initially take count is equal to 0. Whenever this condition is satisfied, you count it, right? Once you finish the loop execution, you can print that count. Printf double quote percentage d double quote comma count. This is a very basic method to solve that problem. So you need to find out how many I values are there, how many I values which will satisfy this condition. But this will take a little more time because we have another method which will, right, which will, okay, which will give the result in a most efficient way. Now, how to count? So the first step is to count, okay, number of zeros, number of zeros or unset bit. We call them as unset bit. So n is equal to how much? Let's take it as 4. Now what we will do here is, what's a binary of 4? Okay, what's a binary of 4 here? 0 1 0 0. Okay, then now what I will do is I'll perform AND operation with 1 0 0 0 1. What is the result now? What is the result now? Result is 0. Correct? This indicates that the LSB bit of the given number 4 is 0. So count it. Count it. Now there is one bit which is correct. Now shift every bit. Now n is equal to n right shift by 1 bit. N is equal to n right shift by 1 bit. So if I right shift n value by 1 bit, the what does the value becomes 0010. This will be the new n value by right shifting it. Okay, this will be by right shifting it. Now when you are doing a right shift, after doing this, repeat the step again. Perform the AND operation with 1. So if you perform the AND operation with 1, if the result is 0, then there is one more bit at LSB which is 0. So count it. How many bits are there now? 2 bits are there. Okay. Now after that, you right shift it one more time. Perform n is equal to n right shift by 1 bit. Then what does the n value becomes? N value becomes 1. That is 0001. 0001. Now perform the AND operation with 1. So the result will be non-zero. The result will be non-zero. That means LSB does not have 0. So do not count it. After that, n is equal to n right shift by one more bit. Each time you shift bit on the right side, check the LSB. Right? Each time you right shift a bit and check the LSB. Is it 0 or not? Okay. So in this one, when you shift it one more time, n value becomes 0. Then stop the operation. Then stop the operation. Are you understanding? So this is how we write a code. Next program to count number of set bits. Right? Program to count number of set bits. Now, do you know that there is one algorithm that we have discussed, that is Bryan-Kernighan. Bryan-Kernighan algorithm. So what does this algorithm will tell us, right? How to unset, right, rightmost LSB. Sorry, rightmost set bit. For example, let's take n is equal to 6. Okay, what's a binary of 6 here? 0 1 1 0. Now if you want to make this rightmost, this is the rightmost set bit. I want to make that bit as 0. I want to change that bit to 0. So to do that, we can use Bryan-Kernighan method, right? What is that Bryan-Kernighan method says? Perform AND operation of a number with its previous number. What is the previous number here? It is 5. So what is the binary of 5? 0 1 0 1. Perform the AND operation. Now look at this bit. Don't you think the bit which was 1, it has become 0? Right? Don't you think the bit which was 1, it has become 0? Correct? Now can we repeat this step again, this operation, by considering this 4 as a new n value? Okay. Now what is the previous number of n now? N minus 1 is how much? 3. Now repeat this step 0011. Perform the AND operation again. Perform the AND operation again. So what will be the result now? Result will be 0000. So entire value becomes 0. N value becomes 0. Now can you tell me how many times did we do AND operation? Right? Till n value becomes 0, how many times did we do AND operation? We did 2 times. Now don't you think this count 2, is it equal to the number of set bits in the given number? Is it equal to the number of set bits in the given number. See, this Brian Kernighan method, what it is doing is, let's say n is equal to, right? Okay, let's say n is equal to, let's say 10. Okay, n is equal to 10. So what is a binary of 10? 1010. Now, if I perform AND operation with its previous number, what will happen? The bit which is set, this is the rightmost set bit. This bit should become 0 in the result. So when does this will become 0? When you perform AND operation with its previous number. So remaining bit will all remain as it is. Correct? Now you take this as a new n value. You take this as a new n value. Then repeat the step. N is equal to 8, which is 1000, right? And previous number n minus 1 is equal to 7. Okay. Then 0111, perform the AND operation. So the rightmost set bit is this. This bit should become 0 here. So when you perform this operation, your result will be, see, only two set bits are there. One by one you start making them 0. Don't you think the count will be, right? How many times you perform AND operation, it will be equal to the number of set bits, right? Correct? Every time you perform this operation, it happens. So let us write the logical part of this program. So first step is what? N is equal to n bitwise AND of n minus 1. Okay. So I need to perform AND operation with its number with its previous number. So every time I perform this, I need to keep counting. Okay, I need to keep counting how many times you perform AND operation. How long we should repeat it? We should repeat it till n is greater than 0. The moment n value becomes 0, you come out of the loop and print the count. Printf percentage %d double quote comma count. Are you understanding this? Right? See, you take n is equal to, let's say, 12. 1100. First, you will make this bit as 0 by one AND operation. Count is 1. Now, second time when you do, this will become 0. So, how many times we did AND operation? 2 times. So, it is equal to the number of set bits. Set bits in 12. Are you understanding? So, we can write a program also to count the number of set bits. You can use this only. You can use this previous logic only. Count number of set bits. Now here, right here, okay, here in the last, instead of 0 you can give it as 1. So this will also give you the number of set bits, but this will take a slightly extra time because we are performing shift operation here. Okay, instead of that we will use Brian Kernighan algorithm. Okay, we will write Brian Kernighan algorithm to do that. So count set bits. So here what we need one count variable which is equal to 0 while n is greater than 0. Inside this, n is equal to n bitwise AND of n minus 1. N bitwise AND of n minus 1. Every time you perform this operation, count it. So once you come out of the loop, return count. Right? So here you can call that function count set bits, pass n as a parameter. That's it. This way, you can use Brine-Kernighan algorithm to check the number of set bits. If I give n is equal to 7, 3 set bits are there. You give 15, there are 4 set bits are there. Now you give 6, there are 2 set bits are there. You give 4, there is only 1 set bit. So like that, you can determine, right, using Brine-Kernighan algorithm, you can check the number of set bits in a given integer number. So I hope you guys are clear on this. Okay. So if you guys are clear, there's one more example I would like to do. Okay. Let's start with that. Okay. Now here, right, check program to check binary representation of given n is palindrome or not. Palindrome or not. Okay. So currently, let us take some n value. Okay. Now, so the data type integer in 32-bit compiler, the size of integer is 4 bytes. Okay, 4 bytes is equal to 32 bits. Okay, 32 bits. So let us write down a number 0000000, again 4 zeros, 0001, then 1 0, then 4 zeros, 4 zeros, and 4 zeros. Now this is 32-bit data. It's a 32-bit data. Now, if you look at this binary, right, don't you think this entire binary which I have written, is it a palindrome? Are we good to go? Okay, very nice. Now, what we will do is, okay, we will go with a two-pointer method, right? We will go with a two-pointer method. Let's take, these are the 2 pointers. One is left, another one is right. Okay, another one is right. Now what we will do is, do you know that we have written a logic or a logic to check nth bit is set or not, right? Okay, we have written a program yesterday to check the nth bit is, right, set bit or not. Is it set bit or not? Do you remember that? Can you tell me um, what was the logic? Which operator do we use? Hmm? Which operator do we use to check? Which operator do we use to check a particular nth bit is set or not? So this is the logic that we use to check, right, the particular nth bit is a set or not. So this condition is, if entire thing is a true, then the bit is set. If the entire result is 0, then the bit is not set. Now if you look at if you look at the position of bits 0 1 2 3, and this is 7, this is 15th bit, this is 16th, this is 31st bit. Okay, so if you look at the numbering of bits or positions of bits, it goes from 0 to 31. Okay, so position value will be 0 to 31. The position values will be 0 to 31. Now what we will do is, initially we will take left is equal to 30, or left is equal to 1, and right is equal to 32. So how do we get this 32? This we can think of size of int multiplied by 8. We can use this because I don't know which compiler I'm working, whether I'm working on 16-bit compiler or 32-bit compiler. Okay, now, so if the both the bits are same, what we will do is we will decrement right and will increment left. Will increment left and will decrement right. Okay, sorry. Okay, let's change the names, right? Let's change the names. Let's consider this as left and this as right. Okay, the I'm going according to the position numbers. I'm going according to the position numbers. Okay, now what we can do is let us start writing a program. Okay, so this number, okay, this number can be written as 1 left shift by 16 plus 1 left shift by 15. This is the n value that we have to give. Okay, this is the n value that we have to give. Let's start working on the example. Okay, so here hash include stdio dot h, then int main opening bracket. So int n, we need only one number as a input. So printf enter number. Let's take that number from the user, ampersand n. So now as we have got the input number, the next thing is, okay, the next thing is decision making. So if is palindrome, let us write a function called as is palindrome and pass n value as a parameter. So this function is palindrome returns 1 if it is a palindrome, otherwise returns 0, it is not a palindrome. So printf, it's a palindrome. If the condition becomes true, it's a palindrome, else we can print it as not palindrome. Okay, not palindrome. Okay, so now what does that is prime function does? Sorry, is palindrome function. Okay, this function, it returns 1 if true, else returns 0. Okay, so int is palindrome, pass the n value. Okay, once you get that n value, so we need two variables, left and right. Left is equal to 1, int right is equal to size of int multiplied by 8. So this will work for 16-bit compiler as well as 32-bit compiler because the size of integer changes. Now, so we should keep on repeating those left and right comparison till left is smaller than right. Okay, I'll explain that in the picture also. I'll show you. So what is the task we have to do? If kth is kth bit set, so we are checking the particular bit is set or not. So I need to send the n value and pass the left index. If is kth bit is set, if it is set and it is not equal to is kth bit set n comma right. So what we are doing here is, I'll just explain. See, this function will check the left bit is set. and this function will check the right bit is set. If they are not equal, then no need of checking remaining bits. Simply return 0. Okay. So then if they are equal, then increment left and decrement right. So like that, you should go on comparing till this point. You should go on comparing till this point. The moment when left value becomes bigger and right value becomes smaller, then you can stop the comparison. So that is the condition. So increment left, decrement right. Okay. So this way, once you come out of the loop, which means all the bits are same. You will come out of a loop only if all the bits are same, left and right bits are same. So if the bits are different, you will a condition becomes true, you will return 0 from the loop itself. Okay. If the control comes outside the loop, that means all the bits are same, left and right bits are matching, so return 1, because it is a palindrome. Now what is the condition here? Right, now what is the condition here? Here I need to write a function for kth bit set. Okay, is kth bit set returns 1, return 1 if set, else return 0. Okay, so int is kth bit set, one second, is kth bit set int n comma int k. K indicates the bit. So how do we check here? Return, sorry, if, right, n bitwise and of 1 left shift by k minus 1. Why we have to do k minus 1 here is because we are starting the left as 1, but the first left bit position is what? The first left bit position is 0. So that is the reason we need to subtract, and this will become 32. So the last bit position is, the last highest bit is 31. So we need to subtract 1 and check, get the correct position. If this value is true, return 1, else return 0. Now let's give the input. I don't know what is the value of this one. Okay, what is the value what we have written here? I think 2 to the power 16 is 65,536 plus 32,768. Oh, addition. We need to do addition here. Okay, let's check. I think it comes around 96,000 something. Okay, so 65,536 plus 32,768 plus 65,536, 98,384, sorry, 304, 98,304. Let's execute and give the input. So one bracket is missing there, one bracket is missing. I was guessing that. Okay, 98,304. It is a palindrome. So I hope you enjoyed today's class. There are a lot of details are there. You just need to keep on practicing them. Thank you for attending.